behind the different smells and the sounds of this ship, and I entered a completely different world. I always felt a direct connection to nature and to this mixture of colors also around me. It's all different shapes of blue and white. I'm Luisa von Albedyll, and I'm a sea ice physicist at the Alfred Wegener Institut in Bremerhaven. I'm studying the sea ice, that is the frozen part of the ocean. My research field is all about the ice thickness actually, how the ice is getting thicker and thinner again. A typical expedition day starts, first of all, with a lot of planning because security is really an important aspect. So we first make sure that we have the right equipment on us so that we're protected against the cold and also against the water. And yeah, with all that equipment and with your sledge, you're gonna leave the boat then, walking down the gangway. You feel maybe the wind and of course the cold, and then when you start to walk, I would say the first thing you hear is this noise of walking on ice and snow. Most people think of the Arctic as a really quiet and flat plain of ice, but it's actually not at all. So it's always in motion. First of all, the whole ice is in motion. The ice normally drifts in the time frame of about a year from the Siberian Arctic towards Europe and is then leaving often the Arctic there. So first of all, that is motion, and within that motion there is also some differential motion. So it's not always going uniformly in one direction, but we have areas where we have this converging ice flows and divergent ice flows again, where we have then the sea ice ridges and leads forming. And that is also not quiet, but you can actually hear those deformation processes because this breaking ice makes a lot of sound, and then also when ice flows are moving on top of each other, it's like this cracking sound, and that's actually quite impressive. Due to the ice dynamics, we realized that it is not stable at all, and that maybe one day could be enough to really move all equipment that was located in Met town, that was for the atmospheric measurements, just a kilometer to the other side. If you then see how power lines are cut, our instruments are almost drowning, then you really realize that this is not just your neighborhood in front of somewhere else here in Europe. So my research field is all about the ice thickness actually, and I'm really interested in the physical processes. So there are two processes that make sea ice thicker. The first one is just thermodynamics, that's the freezing of the ice. It's a bit like what happens in a freezer. And then there's a second process that is more specific to the sea ice, and that is the dynamics. So sea ice deformation, and that means all the processes where sea ice is, for example, colliding. So when we have ice flows that are colliding, then are breaking and pushing ice below and on top of each other and building up sea ice ridges. So that has, of course, a big impact on the thickness. And there's also the opposite taking place when the sea ice flows diverge. Then we form one of those sea ice leads, we call it. It's just an area of open water, a stripe of open water. And those processes are at the center of my research focus.
Ich bin wahrscheinlich die letzte Generation Meereisforscher, die im Sommer auch wirklich das Meereis in der Arktis gesehen hat. Und dieses Meereis wollen wir eben besser verstehen, damit wir es dann auch in unseren Klimamodellen richtig modellieren können, um später dann auch realistische Vorhersagen treffen zu können.
Our current research shows that the sea ice extent decline that we observe now in the Arctic, that this is a reversible process. So it's not all lost, and even though we're expecting Arctic summers without sea ice or with just really little sea ice, we can still change that. So if we really commit us now to climate protection measurements as a society, then I'm pretty sure that we're gonna also witness again more sea ice in the Arctic.